This is the review of the test that I promised. I don't have my writing pen that I usually have today, so we're going to try and do it without that. I may do part of the test and then come back and finish later when I get the pen. Number one, which involves moving metals from a metal, or excuse me, moving electrons from a metal to a nonmetal. That we're looking at ionic bonding because we're transferring electrons to make ions. So metal, nonmetal, always ionic bonding. Electrons are considered to be transferred, not shared. Number two, sharing electrons between two atoms in a molecule. Best answer is covalent bonding. You might be able to make an argument for network covalent bonding because like a diamond or a piece of pencil lead, those are macromolecules. But the best answer here is covalent bonding is sharing electrons. Called that because you're sharing valence electrons, and co means cooperating, so cooperating with valence electrons, covalent. Number three, sharing electrons unevenly between two atoms in a molecule. That's sharing is covalent, but if they're sharing them unevenly, key word there was unevenly, that means that there will be a positive end and a negative end to the molecule, so it'll be a polar covalent. Now, technically, those are really considered partial positive and partial negative, which means that the charge is not as extreme as it is in an ionic bonding situation. Okay, so sharing unevenly, polar covalent. And then, of course, even sharing would be covalent, but it would be nonpolar. So there'd be no positive end, no negative end, nonpolar. Number five, looking at the most uneven sharing of electrons between two atoms in a molecule, the most uneven would be the uneven. That would be caused by a large difference in electronegativity. So you need to look down here and see which ones have the biggest difference. And in general, those are the ones that are going to be furthest apart on the periodic table. So if you look at a periodic table, H is on the far left, O is on the far right. So there's your answer. So the answer would be D. All right, number six, which of the following energy changes is the most exothermic? Exothermic meaning energy out. Well, if you remember, ionization energy is the energy needed to remove an electron. Those were always positive, which means always energy in. Bond energy always requires energy. It's the energy to break a bond. So that's energy in also. Electron affinity and lattice energy are both energy out. But the biggest energy out is the lattice energy, and that's caused by attractions between ions. All right, so that's lots of energy out. The answer then, of course, would be lattice energy. Okay, number seven, most likely to be insoluble. That'd be the ones with the highest charge. So if you look at them, KCl is 1 and -1. Magnesium chloride, it would be set up in a crystal like Cl, Mg, Cl. So really you're looking at a charge here of -1, 2, and -1. So really the charge is a 2 to 1. Same thing over here, or not the same thing, but another thing. Over here you got 1 and -1. Here you've got 2 and -2. And here you've got the same thing, a similar thing to what you have with the magnesium and chlorine. You got a K and an S and a K. So you have really a 1 and a -2, and a 1. So which have the highest charges? Answer D. Because the 2 and -2 will attract each other the most. This is a similar question, again about ionic bonding or ions in a crystal structure. The easiest to pull apart would be the ones with a lower charge. So if you look at them, this is 1 and -1. This is 2 and -1, 1 and -1, 3 and -3, and 1 and -2. So it looks like it'd either be C or A. Then you have to go back to the basketballs versus the tennis balls in a trash can analogy. In which case, could the balls get closer together? It'd be the tennis balls because they're smaller, so there's less space between them. So the ones that are harder to pull apart would be the ones that are smaller, which would be these, because Na is smaller than K, F is smaller than Cl. So our answer, since we're looking for the easiest, would be KCl. So that's your answer because it has a 1 and 1 charge. This has a 1 and 1 charge, but these are bigger ions because they're further down their respective families on the periodic table, so they've got more energy levels. Bigger ions, they can't get as close together, so they don't stick together as well. All right, this is question number 9 now. Which one involves a loss of energy? Would be the one we talked about that a minute ago, up here with lattice energy and electron affinity and so on. The only one here that actually releases energy is lattice energy. So your answer is C. Okay, which one would tend to lose 2 electrons during the formation of an ionic bond? Okay, losing 2 electrons is based on valence electrons. So if the atoms with 4 or less valence electrons will tend to lose to 0. Atoms with 5 or more will tend to gain. All right, so if you look at the number of valence electrons, magnesium has 2, calcium has 2, aluminum has 3, sodium has 1, and rubidium has 1. So you're looking for losing 2 electrons, so either one of these answers would have been fine. Remember I told you there are a couple of questions that has 2 answers on them that were correct, and I'd take either one, so that was either A or B. Okay, how many atoms of magnesium would combine with 2 atoms of nitrogen when magnesium nitride is formed? So magnesium has a +2 charge. Let's do this. Magnesium is a +2. Nitrogen is a -3. So you're going to be looking for a common multiple of 2 and 3, which is 6. So since the magnesium is +2, since that's +2 and that's -3, you're going to need 3 atoms of +2 to make a +6 charge. And 2 atoms of nitrogen to make -6. So the answer to this question was 3. Okay, now we're down to the point where it'd be helpful if I had my pen, and I don't, but we'll see if we can get through this. So which of the following is not polar? Would be hydrogen has to be your answer. Not polar means either, let's say, caused by low difference in electronegativity if there is only one bond. So that category would be here or here. So if there's only one bond, either the hydrogen or the HCl, they both have one bond, but H to H would be zero difference in electronegativity, so that's going to be your answer. Okay, the other thing that can cause not polar when the charge vectors cancel. So in this case, I don't know if I can do this or not, but we'll try. So water is going to have this kind of a shape, like that. It's going to be bent. Ammonia, since it's going to have this kind of a shape, it's going to be a pyramid. All right, and then there'd be a pair of electrons that you can't see. There'd be two pairs of electrons up here around the O, and one pair of electrons around the N. So both of them are going to be polar because the electrons are going to move in the direction of the more electronegative element. So in this case, electrons are going to move that way, and they're going to move this way toward the oxygen. So what's going to happen is these vectors don't cancel each other out. Over here, the vector is going to move toward the nitrogens because it's more electronegative than hydrogen, and they're going to cancel they're not going to cancel each other out either. So these do not cancel. Did I say they'd cancel? They will not cancel, and these will not cancel. So these are both going to be very polar, and these guys are nonpolar. You may remember that we talked about hydrogen bonding, where it's a really, really special type of attraction between two polar molecules, where hydrogen is bonded inside a molecule to a highly electronegative element, such as oxygen or nitrogen or fluorine. And so both of these molecules would exhibit hydrogen bonding, which is very, very strong bonding between attractions. Okay, you're going to need to draw the dot diagrams for this one. The strongest intramolecular bond would be the one with the triple bond. So this carbon dioxide, I'm going to write down what they have. What this has is two double bonds. And this has a single bond. No, this has a triple bond, sorry. This has two single bonds. This has one single bond. So, which one's going to have the strongest intramolecular bond? The one with the triple bond. So the answer is B. Okay, if more energy comes out than you put in, we know that's exothermic, so that was a review of ionic bonding there all of a sudden. Okay, now which is nonpolar? All right, I'm going to stop there and post this one and come back and do these when I get my pen. I think I can, if I can find my pen. All right, thanks.